In this video, I want to talk briefly about vectors. A vector is a quantity with a magnitude and direction. So let's take a look at 4 meters per second versus 4 meters per second northeast. Well, the 4 meters per second is called a scalar because it is just a magnitude. There's no direction associated with 4 meters per second. Versus 4 meters per second northeast, now we have the scalar quantity, which is known as the magnitude, and we have the direction, northeast. So this is actually a vector right here. Let's talk about ways that we can actually represent vectors, and there's actually several different ways. First, you can view a vector with coordinate point 3, 6. That can just be a vector. So that would imply that you're going 3 in the x direction and 6 in the y direction. So coordinates. You can also represent that same vector as a matrix. So you have the x direction would be 3 would be the top number in basically a 2x1 matrix, and then the 6 would be the y component of the vector. So this is in matrix form. You can also have a vector being represented in what's called unit vector form. Unit vector being 3i plus 6j, so I representing the value in the x direction and j representing the value in the y direction. So 3i plus 6j would mean 3 to the right and 6 up. So this is unit vector form. And then lastly, we can have something graphed out. I have 3 different vectors drawn here, but really they're the same. So this is a graphical representation. So graphical. And all these vectors are the same because what you should understand about vectors is that the starting point of a vector doesn't matter. So all 3 of these arrows here, which is, graphically you put the arrow showing the direction, graphically these are all equivalent to vectors because the starting point doesn't matter. What does matter is that we go 3 units, 1, 2, 3 units in one direction, and then we go 6 units, 1, 2, 3, 4, 5, 6 in the other direction, and that's going to be the graphical representation. You can see this vector here, which starts from what's known as like the standard position, which is the origin, and you'll see again that we go 3 in the horizontal direction and then 6 in the vertical direction. Same with this one down below. Again, all 3 of these vectors are actually the same vector because with vectors, the starting point does not matter. Keeping that in mind, let's just do one problem because a lot of them are going to show up in some form like this or another, whether they use a matrix form or the unit vector form or show you a graph or even a combination. You can do with vectors basically what you can do with any other number. So you can add them, you can subtract them, you can multiply them. So let's do this. I have defined 3 vectors here. We have vector AB, represented by a matrix 1 to 2, it's a 2-1 matrix. I have vector CD, represented in unit vector form, 2i plus j. And I have vector EF, which is just represented with the graph. And you can see there that it is actually, if we represented it in a different way, it would be -1 in the x direction and -2 in the y direction, based on the arrow there. Let's solve the equation 2ab plus cd minus ef. What would that mean? Let's solve it with unit vector form. 2ab can be written as 2 times I plus 2j plus cd, which is just 2i plus j. And then EF, so we're subtracting EF, so minus, and then we'll put this in parentheses so we don't lose track of the minus sign. So minus, that would be -I minus 2j. And let's distribute these across, so that gives us 2i plus 4j plus 2i plus j minus -I, so plus I, and then minus -2j, so plus 2j. And let's combine like terms here. So that's 2i plus 2i plus I, so that's 5i. And then 4j plus j is 5j plus 2j is 7j. And there we have our solution to 2ab plus cd minus ef.